All right, as Lisa's getting set up, let's see. Lisa works at a company called Data Strato, and she's going to talk about what they're all about. And just looking at Lisa's background, it's quite impressive. She's worked as a data engineer, and now she's working in product at Data Strato. She's also a Google Women Tech Makers Ambassador, and looks like a big ambassador and a big fan of open source. So welcome, thank you.
Thank you so much for having me. And thank you, everybody, for coming today. It looks gorgeous outside. So the fact that you're watching this is very humbling. Thank you so much. So I'm going to be talking today about metadata lakes for next generation AI ML development, what that means and what that looks like. We're going to get into, but there's a lot of new concepts in here that I kind of want to bring forth, but hopefully some of it looks familiar to you. So a little bit about me. I got a really great introduction already, but I'm a product manager at Data Strato. I have a technical background as a data engineer, and I am an ambassador for a few different organizations in the open source world, including the Continuous Delivery Foundation. I organize a group here called Data Engineer Things, the Bay Area. I'm also on the Linux Foundation AI and Data Outreach Committee, as well as the Gen AI Commons Committee. A lot of what my career has been kind of looking forward to up until this point has been finding this weird intersection between DevOps teams, data engineering / infrastructure teams, and machine learning teams, because I think that there's a lot of incongruency around the way that these teams operate and the way that they communicate. So kind of to get into why I started thinking about this, and particularly in terms of the next gen AI ML steps, I see that a lot of the RAG that we see in demos and applications that we see are kind of at this POC level where we just kind of build this RAG pipeline, and then if you look at step A here, you just prepare the data. The data is just prepared. It just gets fed into this pipeline, and it's so easy. It just comes from this single source. It's already standardized. It's not messy. It's perfectly version controlled. Anybody who works in production with data systems knows that it is a complete nightmare, and that is totally not how it goes down. Everything past this point, I'm going to leave to the Milvis guys to master, but a lot of what I'm going to be talking today is how do we actually get a RAG pipeline into production with the data infrastructure piece in mind. So knowledge management within RAG is also inherently pretty difficult, especially at scale. It's hard to really get a measurable sense in terms of the observability. Even in the data engineering world, and obviously in the DevOps world, we've had observability for a while, but how do we get observability in terms of our actual machine learning pipelines? So what is the velocity of the documents that are coming in? What is the distribution? How do you version control and get the life cycle as people are editing their documents? And how do you actually trace that lineage in a way that's auditable? And obviously, sometimes you get billions of documents. How can you actually manage that in this super messy way with all of these sort of minute things going on? So if you are a data person, you might have heard of this term called data products, which is where you're sort of providing ownership to a specific team over their own data, and they're sort of expected to serve it to other people. I also want to kind of bring this concept into RAG as well, where when we think about RAG, we can also think of RAG as a product as well, right? How can we break up a RAG pipeline and any sort of machine learning application into reusable pieces? This is because in a lot of organizations, what I see is that R&D builds an LLM model and then tests it in like some sort of R&D environment and then passes it off to another team to productionize it, right? What does that even mean? And how do we actually make that reusable and break it down into its components in a way that's standardized? Kind of on top of this as well, RAG has itself gotten more complicated. And as we're doing research and development in terms of getting the best performance out of these models, we also have to think about how, the complexity underlying this will change how we take different systems into production and what kind of underlying complexities that will bring. So for instance, you might have really agentic based RAG, you might have advanced retrieval methods, you might have a mix of different things as well, like past just fine tuning. And all of this has many different implications and costs in terms of performance and in terms of, actual cost, right? So, some of the challenges that you might face in RAG development, and especially when you're keeping in mind these things at scale, is of course having that trade off between how complex querying can be handled and the actual time to return an accurate result. Obviously, the more complex your query and the more complex queries that you can actually use, the longer it's going to take to return a result for you. But the more accurate it's going to be, right? How you provide some sort of synthesis for incoming information over time. This also ties in with continuous learning and updating. This is extremely relevant in streaming systems as well. And this is extremely high velocity, especially when you're considering just how much is coming in and how can you keep things up to date, right? I think there's a huge difference between, models that have access to data that's continuously updated versus those that are kind of stuck in time. And of course, with all of this, there's latency and performance optimization and the governance piece of it, which is how do you actually ensure data privacy and security, right? In that first sort of RAG POC, there's no sort of encryption, there's no masking, it's just kind of a free for all. And in real world contexts, you can't really do things that way. I also want to get into the difference in terms of architecture that we've seen over the years and the difficulties in terms of that as well. So, for instance, in different clouds, you have different silos that occur. So, over time, we've gotten so used to having one specific public cloud provider, or we might be doing things on prem as well. But over time, we actually find multi cloud architectures to be pretty common. Just the general messiness of things ends up that way. And nobody really likes vendor lock in. And so, you might have production worthy pipelines, but only on GCP, right? Only on a very specific set of tools that can guarantee a baseline standard for you. But if you kind of deviate from that, it's extremely punishing. And so, how do you kind of avoid that lock-in? I think we mentioned before, I'm a big open source person, so I'm going to definitely harp on that today. And over time, we've of course seen these infrastructures get more and more and more complex and looser, but also more structured in different ways. So we started out with a very structured, warehouse. As more unstructured data came into play, we played around with different formats. And, I don't even think data mesh is really that widely adopted currently, but there's like each one of these diagrams is much more complicated than the other. And I think that's something that we really need to keep in mind because in that first diagram, that's just step one, data preparation, right? That doesn't really capture that much else. So including how many different cloud providers you have and different tools you have just running your infrastructure, you also then have to implement your actual architecture and how you want to serve this to consumers in your organization, let alone, actual application users. This is another point of complexity where tools have been changing a lot over the past 5 years. This is the 2024 ML, AI, and data landscape. This is not even the entire thing. I actually had to truncate the screenshot just because that was as much as it would zoom out. And each year there are more and more tools added. And so who are the ones that are most likely to adopt these new tools? It is the machine learning engineers, I think, right now. And, architecture is slow to catch up. So how do you actually build architecture that can support all of these new tools that are evolving without necessarily, building all of this technical debt behind it? So to kind of sum up, this is a terrible slide, but I think it's true in a lot of organizations that we have a lot of different silos at different levels of an organization. So obviously you have an operational silo that can occur just depending on who's working with what data and what's relevant in that sense. And especially if you're working in different data centers across the world that are, kind of type locked there. Of course, the type of data and the format, I think that open formats are getting more popular now because this is such an issue, but, really that this is hard, right? How do you operationally create consistency in your data across an entire organization? There's also silos within teams themselves. So a team of BI analysts versus a team of data engineers versus a team of, again, DevOps engineers will have access to completely different tools and won't even talk to each other. And they should be talking to each other, but oftentimes they don't. And they're all using different specialized tools within that specific system, which creates further technical silos as well, right? And again, this is part of that tooling silo where the language is so specific. Oftentimes, I've met like DevOps teams that are trying to get into this idea of deploying machine learning applications, and yet they literally can't understand the language that machine learning engineers are using. And this becomes this further divide. So there's a lot of just messiness just beyond architecture as well that we can look at. And this becomes a huge disadvantage because if you're building a company-wide knowledge graph to power a machine learning model or an LLM that you want, you need unification of all that data at some level, and you need to manage it in an actually like solid way. And different teams are going to be using different execution engines, different data stores, and they're going to have their own specific way of doing it. And then you're managing your legacy data architecture on top of your modern data architecture as well. It's just a complete mess. But if you want like good performance out of your like LLMs, you kind of need to unify it and standardize it in some way. And if you want to productionize it, there's you need to govern it, right? And so how can we create flexible architecture that can account for all of this and still enable R&D to do what it wants to do and drive organizations forward with their innovation without totally telling them, hey, we have to wait like 3-4 years before the architecture can actually get into a place where the data quality is good and it's actually unified. So this has kind of been solved in a lot of ways through metadata. And the way that we've tried to do it is by creating metadata wrappers around different applications in order to then serve to organizations as well. This has kind of been really interesting in terms of how we create that layer. So if we go back here, you can see that there's a unified metadata management layer in between everything that sort of sits on top. And oftentimes, and the reason why I used metadata lake instead of a data catalog is very specific. And this is because a technical metadata management system will be very different from a consumer-facing metadata management system. And as part of that, we're seeing the differences here where instead of just having a common semantic layer that's like a business glossary or something similar like that, where people can pull and interact out of, we're having active metadata that's then embedded within different applications in these different layers that can be triggers to things like orchestrated pipelines, metadata analysis, observability. And of course, we see how powerful metadata is just within a RAG pipeline itself. And with that comes governance built in. So why is this really important, right? Obviously, there's data discovery that's part of this, kind of knowing what data is available through having a catalog. But essentially, there's a lot of different parts of this that really come into play when you have rich metadata given throughout your applications. And if you can unify it and pool it into one single place, then you can have a single team manage it and serve it in a way that is actually useful to another team. And a lot of this is sort of classifying your data in accurate ways, doing masking, doing metadata enrichment as well, and connecting, of course, all of these different sources together through like a unified architecture. And so I said that I was part of an open source project before. That project is Apache incubating Gravitino and Datastrato's kind of flagship repo that we pour all of our resources into. And so we provide a single metadata catalog that you can actually plug in all of your different sources to and then use your query engine of choice to actually plug into as well. So it's a technical data catalog and it's a metadata lake because we kind of have a more loose approach to how we use metadata in terms of just being very prescriptive. So for instance, if you have, in your company Hive Metastore and you have Amazon S3 buckets and you have all of these different types of catalogs or different data stores, we allow you to then register it into the metadata lake and then control it and actually have another infrastructure team manage it through that single plane. I'll get into this more a little bit later, but that's kind of the idea is that throughout all of your different teams who are using this data in different ways, how can you create a single plane that then they can interact with while still having the guardrails there? So the idea of Gravitino is to have a multi-cloud architecture compatible data catalog. So regardless if you're on an AWS ecosystem, Microsoft Azure, Databricks, or GCP, or you're working with on-prem, you can actually interoperably work in those ecosystems without necessarily having to move all that data into one single place. This is our federated querying approach. And then through this, you can have a layer that sits on top of all of those clouds and have things like access controls, data lineage. You can optimize queries, and then obviously auditing becomes a lot easier across different systems. And this is also really important if you're working with geo-distributed data centers. So there's a lot of really cool reasons why it's very useful for this, and it's very consistent, right? Our architecture is pretty straightforward here. We're very, API first at the moment. We do have a UI that's being built out currently that is more enterprise friendly. We do have a basic community UI though, but we were one of the first to build an Iceberg REST catalog. And we actually serve everything as a REST API for your different applications and teams to kind of push and pull with. And so the idea here is that underlying, you'll have a bunch of different connectors to different things. So let's say you have a Kafka stream connector and you have, an AWS S3 bucket connector or some sort of like JDBC catalog or warehouse or other unstructured data. And then what that does is that it gets converted into a common schema and then registered into our catalog, which is then present into the metadata lake. The metadata storage currently is within cache, but you can plug in your own metadata storage, so it doesn't actually get sent to anywhere else unless you define it to be. And then it gets served within that one single layer. And you can also register models. That's something that we're currently working with because we kind of want a full end-to-end view. And of course, this slide is a little bit more technical, so I'll kind of skim over it a little bit. But the point of this is just that in order to handle non-tabular data, we actually do use a virtual file system along with Arrow to be able to give you the same functionality that you would with your normal tabular data. And the idea here with all of this is that one team might use Trino, one team might use Spark, one team might just use a normal like MySQL setup. And we want them all to be able to query the same data in a federated way without physically moving that data to the same place and actually have consistency between all of that. And that's kind of the idea, right? Is that you can serve it to any team and then that metadata persists in whatever changes you decide. And if you have certain access controls over it, if you plug it into another framework, you can then have more fine-grained control like row column masking, etc. So this is kind of our idea of what data governance is kind of going to move into as we talk about machine learning and AI governance as well. This is extremely important, especially if you're trying to have a messy architecture but move everything along a pipeline. And as we're bringing in different data transformation tools, we want to have this idea of how can you actually catalog your transformations? How can you catalog along those sources? How can you have that full lineage? And then once you're in production, how can you retain all of that in the same place, right? So I don't think catalog RAG is totally a real thing. I think that in what we would expect it to look like is that it would sit below, vector stores and knowledge graphs, because I think that hybrid formats is so popular. And the idea is how can you really safely and in a nice governed way without, really slowing down your machine learning engineers, have them do what they want to with all of the tools that they want to. And if they want to do a whole knowledge graph across the entire company, how can you easily set that up despite everything underneath being really gross, right? That's kind of the idea, is how do you have a catalog that then knowledge graphs can pull from or that vector stores can pull from as well? And then can you govern within that? So our kind of proof of concept of what we've used so far in terms of getting this idea through. And we've kind of talked about RAG a little bit, but essentially our idea is down the road, we'd love to kind of have these built-in generic agents that are embedded within the catalog that can then interact with systems in a really intelligent way, in a tool agnostic way as well. We have a Colab notebook here that you're welcome to go through, and this kind of shows us being the backbone to Llama Index in this case, and having agents interact with our actual data catalog. We're still pretty early stage in sort of getting this through in a way that is super production ready, but this is our idea so far. We've focused so much on being this amazing data catalog that now we want to master being an AI catalog. So a little bit about our community and what we do. So again, I kind of talked about like our idea being the bridge between a machine learning team and a data infrastructure team, right? And this is kind of where we've come from and where we're going so far and how we imagine, these different teams interacting with us. But we also want to kind of make note that we have done so much work around the federated querying in multi-cloud environments. So again, we're trying to bridge everything across organizations together and allow tools to be used in the way that they should be used without having all of this technical debt behind it, with including global data compliance. So again, because of the federated nature of our catalog, you can query the metadata with the source data staying in place, and then the join happens either in memory or somewhere else where you define, and then you don't have to worry about it anymore. And you can also do tag-based masking as well for additional security, for whatever you need to do in terms of having that governance in place. And then you can also build data agents as well that can interact directly with Gravitino, depending on how you want that to look, either as generic or as specific as you want. All of the data within the catalog is available. But yeah, I think it was 2 weeks ago now, our vote to become an Apache incubating project passed. And this was really important for us because if you don't know, the past couple of weeks in the data world have had a lot of catalogs rise up very randomly. And this is something that we were prepared for, but it's worth noting that we open sourced our project on December 12th, 2023, and you can see that our stars have grown a lot, even way more since this screenshot was taken since then, which we're really happy about. And on June 13th, 2024, which is, I think, like 2 days after Unity Catalog OSS was announced. Again, we're open source people, and so that contributor number is actually 100 right now. We raised from 80 to 100 within that short time. We have 187,000 lines of code versus at the time on June 13th, there were only 0.17K lines of code for Polaris and 25K for Unity, and the number of commits that we've had. So we've had almost 1,400 commits. I think it's probably way more than that by now. Versus 2 commits and 2 commits on each open source project from Polaris catalog and the Unity catalog OS. Of course, over time, this will change. But to me, that's kind of like a README and like an update README, pretty much. Like it's very bare bones. And, in terms of issues, we have almost 4,000 issues at this point. And so we've been developing very openly, and we are vendor neutral as much as possible. And we think that there's a lot of silos that will occur depending on the favoritism and developer experience that different catalogs will offer. So that's kind of been our part. If you're interested in our community and more about Gravitino, you're welcome to join our community. We'll be moving over to more Apache-based community resources pretty soon as well. And so if you just want to start our GitHub repo, that's always a helpful thing that you can do to support open source. And yeah, if you're interested in contributing, we have a lot of documentation out there. But also we do have a tag called Good First Issue. So if you're new to open source and you're interested in getting, part of the community, that's always a great place to start. And yeah, we have also many social media links and websites. I'll let you just Google Datastrata or find me on LinkedIn if you want to. And we also have a very vibrant community of different users who are using us in production currently, as well as who are actively contributing code to us. And so, yeah, thank you so much for listening to me ramble.